Okay, lesson 65, part 2. Graphing logarithms. Okay, well, if it's graphing logarithms, why am I starting with the definition of an inverse? I'm starting with the definition of the inverse because this is the easiest way to get you to graph a logarithm. All right, what does an inverse do? If I put x into a function, what comes out? F of x. If I put that back into the inverse, what comes out? What I started with. For example, if I take x plus 5 and I subtract 5, I end up with x. Or if I take 3 times x and then divide that by 3, what comes out? X. Well, in the same way, and we've been seeing this a lot recently, 3 raised to log base 3 of 5 is 5, or 3 raised to log base 3 of x is x, and log base 3 of 3 to the x is x, right? So logarithms and exponents are inverses of each other. If I put x, I'm just going to call this one e to the x. So if I put x into e to the x, what comes out? E to the x. Well, if the inverse of that is the natural log of x, what comes out? What comes out is the natural log of what did I put in? I put in e to the x, so that's x times the natural log of e. Natural log, we know, is log base e, which is 1, so this is x, exactly what I predicted. If I put x into a function, take what comes out, put it into the inverse, what comes out is the original. So the input of the first function is the output of the inverse. The input of the original function is the output of the inverse. All right, so that's the definition of the inverse. So let's just show you this. If we remember that logarithms and exponentials are inverses. So if this is y equals log base 3 of x, the inverse of that, how do I write the inverses? I switch the x's and the y, right? So to write the inverse, I would write x equals 3 to the y. Take the log base 3 of both sides, so log base 3 of x equals y. To write the inverse, you switch the x and the y. Well, here on this exponential equation, whenever we graphed an exponential, the points we were interested in was when the exponent equaled -1, 0, or 1. Well, -1, 3 to the -1 is 1/3. 3 to the 0 is 1, and 3 to the 1 is 3. Well, the input becomes the output of your logarithm. So your logarithm then, if I'm getting out -1, what am I putting in? Whoops, switch colors. What I'm putting in is 1/3. If I'm getting out 0, what I'm putting in is 1. If I'm getting out 1, what I'm putting in is 3. All right, how did we write an inverse? We switched the x and the y. So how do I find my points? I switch the x and the y. Instead of -1, 1/3, the point is 1/3 -1. Instead of the point 0, 1, the point is 1, 0. Instead of the point 1, 3, the point is 3, 1. All right, so let's do a quick graph of one of these. This is, I know you all are thinking this is way more complicated than the textbook makes it, but this is to prepare you for calculus. In calculus, you're going to be finding graphing. You need to be able to find the graphs of inverses that are not straightforward and simple. And the easiest way is to take your other ones and to take the original function and just switch the x's and the y's. So I'm going to get you started doing that here. All right. So this is what they're asking me to graph, y equals log base 3 of x. So I need my x's and my y's for log base 3 of x. Well, I'm going to start by writing the inverse. How do you write the inverse? Do that in that color. How do you write the inverse? you switch the x's and the y's. So this gives me x equals log base 3 of y. How do I solve a logarithm? I say 3 to the x equals y. Aha! I know how to quickly find xy points for an exponential, right? I'm interested in -1, x equals 0, and x equals 1. When x equals -1, this is 1/3. 3 to the 0 power is 1. 3 to the 1 is 3. So the points here are -1, 1/3, right? X equals 0, y equals 1, and x equals 1, y equals 3. I'm going to kind of exaggerate these a little bit. 1, 3, 0, 1, -1, 1/3. And we know an exponential looks like this. Right? So that's what my exponential, 3 to the x equals y, but they didn't ask me to graph an exponential, did they? They asked me to graph the logarithm. Well, how did I write the exponential? You switch the x's and the y's. So I'm going to take these points and switch them. So I'm going to say when x equals 1/3, y equals -1. So here's 1, so here's 1/3, y is -1. When x equals 1, y equals 0, right? I'm just switching these x's and y's. X equals 1, y equals 0, x equals 1, y equals 0. So this is the point 1, 0. This is the point -1, whoops, well, 1/3. I'm sorry, 1/3 -1. Where's my eraser? There it is. This is the point. This is the point 1/3 -1. And then my last point that I'm going to plot is when x equals 3, y equals 1. So 1, 2, 3, y equals 1, 3, 1. So this one, the logarithm, is going to look like this. So what do we know about the domain of a logarithm? It has to be positive. It can't be 0, right? X can't be 0. It has to be positive. Well, if I were to have carefully graphed this, and if you graph them on your calculator, it shows, and do a square, a z-square, you'll see that this is just reflected across the line x equals y. So if you flip the x's and the y's, you end up with this is your logarithm and this one as your, let me see if I can make this a little smoother, and this one as your exponent. Alright, so logarithms and exponents are inverses of each other. The easiest way to graph these is to find your points for the exponential and then flip them and make them your points for your logarithms. Okay, have a good Christmas.